Hey everyone, welcome to the lecture series of Elementary Classical Mechanics, where we can embark our journey from basic to advanced physics. This is lecture number 1, presenting on one-dimensional motion. One-dimensional motion or 1D motion is the study in physics where we consider the motion of a particle in single dimension, just like a bead in abacus, which is restricted to move along the wire back and forth. So let's get started. Once particle nature in physics, we must start by knowing the location of body. Then we can start working on the rest. The position is a location of a body or a particle, or in a crude language, a thing. So for example, look at the diagram below. On the x-axis there are two things, a school and a home, and they are 2 kilometers away from each other. Therefore the position of a school is at x equal to 2. Now we know what is the position. We can use this information to understand what is displacement and distance. Displacement will give us more descriptive information of the body rather than the distance. SI unit of distance and displacement is meter. The displacement is the change in position from the final location to the initial location. In a mathematical way, it is simply given as delta x equal to x sub f minus x sub I, where x sub f is the final position and x sub I is the initial position. The symbol, which looks like a triangle, is change of some quantities. So in this context, the change in position. So delta x. A displacement will tell you direction of object and how far it is going to get. But distance will give you how long the object will go and no information about the direction whatsoever. Let us understand by an example. Mr. Smiley is rolling around on the meter scale on the x-axis. He travels from position between x1 equal to 2 and x2 equal to 7. And we need to find the distance and displacement of Mr. Smiley between these two positions. As the definition of the displacement is change in final position to the change in initial position, therefore substituting the respective values of initial and final position, we get plus phi. The displacement is plus phi. That is, Mr. Smiley has covered 5 meter in positive direction, and distance will be just phi, no directions. Remember, strictly, the displacement depends upon only on initial and final position and not in between that. Let us take another example where we need to find the position of Mr. Smiley. This time the axis taken is from negative of numbers to positive of numbers. We need to find the displacement between final and initial position between x1 equal to minus 3 and x2 equal to 2. Similarly, as before, substituting the respective values of x1 and x2, we get the result as plus phi. Here, the displacement is plus phi, that is Mr. Smiley has covered 5 meters in positive direction and distance will be just phi, no direction. Now what happens when the object takes the trip like this? How do you do that calculation? Please pause the video and write out yourself. Let's write down the positions first. x1 is minus 3, x2 is plus 4, x3 is minus 1. So this time we first calculate the distance for the first trip the block travels in between the position x1 and x2, and the difference is 7 meters. For the second trip, the block travels back from the position x2 to x3, and that difference is minus 5 meters. But remember, for the distance we take only magnitude, not direction. So second trip distance is phi. Now adding them both we get 12 meters. Now the real color displacement shows when concerned with this kind of pretty complicated situation. We take by definition only the initial and final position. Therefore, the displacement will be just plus 2 in positive direction. In this lecture, I have talked about some new terms like scalars and vectors. Well, don't worry about those. We will have separate lectures on this concept. But for the meantime, just remember that scalar quantity will just give us magnitude in the result of problem, and vector quantity will give both magnitude and direction for the output of the problem.